Okay, today we're going to start chapter 3, which is about probability. And we're going to start out the chapter by learning the correct terminology and definitions. Okay, so this is going to be a lot of definitions. So number 1 is the word experiment. And what that is, there are different ways that you can define it, but I'm sticking with our book, and they use the definition: a planned operation carried out under controlled conditions. Okay, the next word is the word chance. Okay, it's an additional word that you add on to the word experiment sometimes, and that is if the result is not predetermined. If the result of an experiment is not predetermined, it is called a chance experiment. So that would be like flipping a coin, a regular fair coin, not a trick coin. Okay, you don't know if it's going to come up heads or tails. That's called a chance experiment. Okay. The result of an experiment is called an outcome. Oh, that did not come out correctly. Let me write that correctly. And let's do the second definition here in the same sentence. Actually, no, I'm going to start a new sentence so that they're not too jumbled up. Okay, so the next one is the set of all possible results of an experiment is called the sample space. All right, more definitions. An event is any combination of outcomes. Okay, and I would like to stop right there and just practice these words a little bit. So, let's write example. So suppose you're going to flip a coin twice. Okay, so that would be what's considered a chance experiment, okay, because it's a planned operation. I plan to flip the coin. It's carried out under controlled conditions, meaning I'm going to flip it up in the air and catch it. I'm not going to like throw it out of a moving car or something like that. Okay, I'm just going to flip it right in front of me and I'm going to catch it. All right. And the outcome is not, let me not use the word outcome yet. The result is not predetermined. I don't know if I'm going to get heads or tails. Okay, so that is a chance experiment. Okay, all right, now let's list the possible outcomes. So what might happen when I flip a coin 2 times? I might get heads twice. Let's write it like this: heads, heads. I might get heads and then tails. I might get tails and then heads. Or I might get 2 tails. Those are the possible outcomes. Okay? So the sample space looks like this. The sample space is the set of all possible outcomes. So you use these curly braces or brackets for set. Those are called set brackets. And I just put in here the 4 possible outcomes: 2 heads, heads and then tails, tails and then heads, 2 tails. That's called the sample space right here. Takes up a lot less room to write it in an organized fashion like that rather than listing them out. Okay, so let's erase this list. Okay, and I'll just make a note here. These are the possible outcomes. All right, now let's talk about the word event. It's very common to get confused between event and outcome. Okay, like somebody might say, you know, in the event that you flip heads twice, so heads, heads is considered an event. But wait a second, we said that heads, heads is called an outcome. So which is it? So here's the answer. The answer is it's an outcome, and it could also be an event. But the point about event, look at the definition. It says an event is any combination of outcomes. So therefore, each outcome is also an event. But the word event has an even broader use. you could put more than one outcome together, and that would still be an event. No longer an outcome because it's multiple outcomes. Multiple outcomes can be put together to form one event. Here is an example. I'm not going to do all possible events because there would be 16 of them. But let's just write down one just so you can get a feeling for it. Okay? You could, well, we'll do a couple actually. So you could say, I'm going to flip the coin twice, and I'm wondering if in those two flips I get exactly one heads. Okay? So let's write some events. Okay, so one example of an event would be getting exactly one heads. I don't know if it would be proper to say one head or one heads. I don't know. Okay. What would that look like? That would look like this. Heads and then tails, or tails and then heads. You see, it is a combination of outcomes. That's an event. Okay. Another mathematical word for it is to say that an event is a subset of the sample space. But in probability, they don't often use that terminology. Okay, here's another example of an event. Getting heads on the first flip. That would look like this. Heads, heads, or heads and then tails. Okay. Another possible event would be getting the same thing twice. And that would look like this. Heads, heads, or tails, tails. Okay, and I'll do one more. How about getting at least one tail? What would that look like? It would be, it can include heads and then tails. It would include tails and then heads, and it would include tails and then tails. So there's 4 examples of events. I can tell you that there would be a total of, I said 16, but I think it's actually 15 possible events. So there's 4 of them. Okay? All right, now let's move on. A couple more definitions I want to cover here. Okay, let's make this a little bigger again. So I want to tell you, what does it mean to say the probability of an outcome? All right. The probability of an outcome is the long-term relative frequency of the outcome. That's the meaning of the word probability. Of an outcome, actually, that's an entire phrase. Okay? And then you have the probability of an event. Remember, events can have more than one outcome included. So the probability of an event is the long-term relative frequency of getting an outcome included in the event. Okay, now let's remind ourselves what words like relative frequency mean. Okay, so in our book, we are mostly, not always, it's not a rule, but we are mostly going to be using capital letters to stand for outcomes or events. Okay? And then to say the probability of that outcome or event, we'll use a capital P with parentheses. Okay? So let's do an example here. This one's going to be simpler than the last example, which was tossing two coins or tossing a coin twice. In this example, we are going to do just flipping a coin, just one coin, just one time, okay? One flip makes up the whole experiment. But we are going to do the experiment many, many times. Okay? Not like here where you might say, oh, you mean like how we did it twice in the first example? No. In the first example, two flips made up the experiment. Okay? So flipping twice would be doing the experiment once. Down here, it's a different experiment. Flipping once is doing the experiment once. Okay? I'm going to, though, do the experiment many, many times. Suppose that I do it, let's say, 10 times. Okay? And what if I get these outcomes? Tails the first two times, and then a heads, and then a tails, and then 3 heads in a row. How many is that? That's 7. and then maybe a tails, and then a heads, and then a tails. Maybe that'll happen if I do 10 flips. Okay? I want to remind you what the term relative frequency means. So in that happenstance of doing the experiment 10 times, okay, so let me write that down. Suppose we do the experiment 10 times and get those outcomes. Okay, so what I can write is this: the probability of tails, okay, equals, now there's two parts to the definition. Look back at the top of the screen. What two parts are there in the definition of probability? There's long term and there's relative frequency. So let me ask you a question. Doing the experiment 10 times, what was the relative frequency of tails? I want to remind you what relative frequency means. The frequency was 5. The frequency was 5. The relative frequency is 5 divided by 10. Okay, that's what the word relative adds on to there. You divide the frequency by the number of repetitions. So the relative frequency in this case was 5 out of 10, which is a half. And you might say, yeah, I know, if you flip a coin, you should get tails half the times and heads half the time. Well, no, that's false. There's no rule that says that. I have flipped coins lots of times before and not gotten tails half the time. You know, I could say, let's do this. Instead of 10 times, what if I said you're going to repeat the experiment 20 times? And maybe we got those 10 listed already as the first 10, and then maybe we got after that heads and then tails on the 12th time, and then 2 heads after that. And then a tails, and then 3 more heads, and then a tails, and then a heads. That's totally possible. And in that case, what's the relative frequency of tails? Well, the frequency is 8, and there was 20 repetitions, so the relative frequency would be 8 over 20, which is not half, is it? That's 0.4 instead of 0.5. Okay? The relative frequency can go up and down as you do the experiment more and more times. Now, let's throw in the phrase long term. What does that mean? That means if you theoretically did the experiment infinitely many times, what would you expect the relative frequency of the outcome to be? And that's where we get 1/2. I can't flip a coin infinitely many times. That's humanly impossible. But if the coin is a fair coin, then I can reason out, you know, using my intellect, I can reason out that if the coin is a fair coin, then the more I flip it, the closer to half heads and half tails I should get. So we would say the long-term relative frequency of tails would be half. And the long-term relative frequency of heads would also be half. Okay, that's what the term probability means. And one thing I want you to notice, I'm trying to move that and it's not moving there. I'm just going to leave it there. And one thing I want you to notice is that because probability is a relative frequency, then what's the smallest it could ever be? Think about that. Well, it's possible for a relative frequency to be 0. The thing might never happen, in which case the relative frequency is 0. Okay? The relative frequency could be as big as 1. If the thing is guaranteed to happen every single time, then the relative frequency will be 1. So the relative frequency can be as small as 0 and as big as 1, and it can be anything in between. And that's important to remember, that probabilities are always between 0 and 1 inclusive. Okay? And what we just talked about, that example, involves something called the law of large numbers. And this is the last definition we're going to do today. The law of large numbers. Okay, and what this says is, my pen is not working very well, and that's why it's showing up very weird. So the law of large numbers states that the more times we do an experiment, the closer the relative frequency of an outcome gets to its probability. I'll explain this in a minute. What does that mean? It means just what I was talking about in the example. Okay, it means that if you flip a coin 10 times, you will not necessarily get tails half the time. It's possible to get 10 tails. Very unlikely, but it's certainly possible. Okay, but the more times you flip, the closer to half of the time getting tails you will get. Okay? So it just might happen that you flip the coin 10 times and you get 10 tails. But if I flip it 100 times, it is less likely to get 100 tails. I am more likely to get closer to 50 tails out of 100. And if I flip the coin 1,000 times, it is even more likely to get 500 tails, or closer to it. The more times you do an experiment, and if you measure the actual relative frequency of an outcome, the more times you do the experiment, the closer the relative frequency is to the probability. Okay? All right, and that is it for the definitions, and then in the next lecture we'll actually start doing some formulas for computing probabilities of different things.